The 9th century marked a pivotal moment in the history of warfare, the invention of gunpowder by the Chinese. This groundbreaking discovery not only changed the way battles were fought, but also laid the foundation for one of the most crucial elements of modern warfare: ammunition. The first bullets were simple, often just heavy lead spheres with no aerodynamic design or precision. However, over the centuries, from ancient battlefields to the high-tech era, bullets have evolved into revolutionary products combining the brilliance of material science, chemistry, and aerodynamics. This is the journey we are about to explore, from crude lead balls to modern bullets with exceptional precision and destructive power. Every modern bullet starts with carefully selected raw materials, including lead, copper, and occasionally steel or tungsten, depending on its intended use. Lead. Known for its malleability and high density, lead is often used as the core of bullets. It helps maintain a stable trajectory and increases the destructive effect upon impact. Copper. Ideal for bullet jackets, copper is highly durable, corrosion-resistant, and heat-tolerant. The copper jacket enhances the bullet's ability to penetrate targets while reducing barrel wear. Steel or tungsten. For specialized bullets, such as armor-piercing rounds, steel or tungsten cores are used to improve their capability to breach hard targets like armored vehicles. In addition to the bullet body, two other critical components are propellant and primer. Propellant. Typically a blend of nitrocellulose and nitroglycerin, the propellant generates a powerful explosion to launch the bullet from the barrel. Primer. A small but vital component, the primer ignites the propellant when struck. It contains sensitive chemicals designed to trigger a rapid reaction upon impact. The manufacturing process of a modern bullet is a meticulous combination of advanced technology and high precision. Processing raw materials. Lead is melted and cast into ingots, which are then extruded into wires or shaped into bullet cores. Copper is rolled into thin sheets, cut, and formed into cups that will encase the lead core. This jacket gives the bullet structural integrity and enhances its aerodynamic efficiency. For armor-piercing rounds, steel or tungsten cores are precision machined to ensure optimal shape and size for penetrating hard targets. Assembly. The lead core is carefully placed into the copper jacket. The bullet is then shaped according to its specific design, whether pointed for aerodynamics or hollow-tipped for controlled expansion. Propellant is loaded into the cartridge case, along with a primer at the base. Quality control. Every bullet undergoes rigorous quality checks to ensure consistency in size, weight, and performance. Test samples are fired to verify velocity, accuracy, and penetration capabilities. Once quality checks are completed, the finished bullets are sorted, carefully packaged, and prepared for delivery. Each box is designed not only to protect the bullets during transport, but also to provide clear labeling of caliber, type, and quantity for ease of use by consumers. Looking back on the journey from raw materials to the modern bullet, it's evident that these are not just tools of war, but also symbols of technological innovation. The evolution of bullets reflects centuries of research and development, from the first crude gunpowder weapons to today's high-tech designs. Whether you see bullets as instruments of conflict or achievements of engineering, they remain a powerful testament to human ingenuity. And in the future, we may witness breakthroughs that go beyond our current imagination. What will the next generation of bullets look like? Only time will tell.